Hello, this is Leah Applegarth again. We are tackling today lesson 2-1, which is relations and functions. Our learning objective is to graph relations and to identify functions. So my students, make sure you have this header filled out. We're going to fill in the notes section today. At any time, you can fill in this left-hand margin column with the questions and the main ideas. All right, just so that you guys know, no need to write this down. The essential understanding is a pairing of items from two sets is special if each item from one set pairs with exactly one item from the second set. And now you must write this down. A relation is a set of pairs of input and output values. It's a set of pairs. I also want you to write down this key concept: 4 ways to represent relations. The first way we can represent a relation, and we've done this before in math, is with ordered pairs. Your first item in an ordered pair is an input, and your second item in your ordered pair is an output. We usually write this as x, comma, y in parentheses. And so I want you to write these 4 points underneath x, comma, y, because we're going to represent these 4 relations in 4 different ways. So the second way that you can write a relation is with a mapping diagram. Your input goes in the left column and your output goes in the right column, and you draw an arrow to show which value goes with which output goes with which input. All right, and then we can also make a table of values, and we have definitely done this before in math, where your x values or your inputs are in the left-hand side and your outputs are on the right-hand side. And last but not least way we have represented relations is with a graph. So there are 4 points here on your graph. You're going to graph them x first and then y second, and they can be represented by a graph. All right, so we're going to take a look, make sure these are written down. In your notes, I do want you to circle ordered pairs. So put a circle around ordered pairs, and in this case it would be a bit of an oval, and then put a box around graph, since those are 2 of our more typical ways that we represent it. So when I check your notes, you guys you'll have a oval around ordered pairs and a square around graph. All right, let's do this problem. Go ahead and write down January 69 degrees Fahrenheit, February 70 degrees Fahrenheit, March 75 degrees Fahrenheit, and April 78 degrees Fahrenheit. So let me highlight what you guys should write down in your notes. February 70, March 75, April 78. So it's asking us, how can we represent this relation in the 4 different ways? So we are going to write it as an ordered pair. So I'm going to call this OP. I'm going to write, we usually use what number to represent the first month of the year. And that is 69. February is usually represented by 2. March is usually represented by 3. And April is usually represented by 4. Okay, the second way with the mapping is we're going to have an input and an output. So we've got an input of 1, 2, 3, 4, and our output is 69, 70, 75, 78. And we arrow. I don't know what happened to that arrow there. And then my table of values looks like X for the input and the Y, which is the output. So I have 1, 2, 3, and 4, 69, 70, 75, and 78. And last but not least, my graph. I'm going to go legit on this one and get X and Y axis. Although I don't like that. And on my x-axis, I need a 1, 2, 3, 4. And on my y-axis, I need a 69, 70, 75, and 78. So I'm going to count by tens. 40, 50, 60. 70. I guess we should put 80 down there too. Alright, so now I need to plot those points. You guys plot along with me. And at 1 I have 69. So if I'm counting by tens, it's 10, 20, 30, 40, 50, 60, 70, so right below. At 2, we are at 70. At 3, we are at 75. At 4, we're at 78. Ta-da! And that's as hard as it gets. Okay, make sure you pause and get all these 4 ways to represent relations down on your paper. All right, I also want you to write down the domain of a relation is a set of inputs, also called x coordinates of the ordered pairs. So our domain is what we input into our relation, and our range is a set of outputs. So domain is inputs, range is outputs. Domain is x coordinates, range is the y coordinates. So we look at an example problem, so go ahead and write the definition of domain and range in your notes. Go ahead and put a star next to the domain and a star next to the range, just to star those out. Write the sample question on your notes as well. What are the domain and range of this relation? So what I like to do is, for domain, I like to list the numbers. So for domain, I'm going to list the numbers, and then I'm going to order them from least to greatest. So we have -3, 0, 2, 9, and 23. I'm going to rewrite them in order. I'm looking, nope, they're already in pretty good order. All right, so now it's the range, and that's 14, 7, 0, negative 18, negative 99. Now I'm going to put them in order. And I got negative 99 is the smallest, negative 18 is the second smallest, 0, 7, and 14. So this is the range, and this is the domain. All right, if a number repeats, you don't have to write it twice. Write that on your paper. If a number repeats, you do not have to write it twice. Okay, so please write this definition of a function down. A function is a relation in which each element of the domain corresponds with exactly one element of the range. So the rule of thumb is domain can have two of the values in the domain can meet up at the same range value. But one domain value cannot have two range values. If you think of it as input and output, I need predictability. I need to know when I plug in 2, there is only one value that I get out as an output. In this case, because 2 goes to negative 3 and 3, this is not a function. And it's because this 2 is 3 and negative 3 and positive 3. Now, 2 can be negative 3 and 3 can be negative 3. It's okay to get the same outputs with 2 different inputs, but the vice versa cannot be true. All right, so let's take a look at this one. I'm going to rewrite, so I'm going to look at each of my inputs. Negative 7 gets me out 14, 9 gets me out negative 7, 14 gets me out 7, and positive 7 gets me out 14. So if I draw the map of this, so negative 7, then it's 7, then it's 9, then it's 14. So here's my domain all ordered, and my range is negative 7, 7, and 14. Okay, so negative 7 input gives me out a 14 output. 9 gives me out a negative 7 output. 14 gives me out a 7. 7 gives me a 14. So it's okay that negative 7 gets you 14 and positive 7 gives you 14. So this is a function. Because none of my x values give me 2 different outputs. All right, there's a little bit of an easier way using our graph to test for function or not function, and that's the vertical line test. So please write this down. Vertical line test states that if a vertical line passes through more than one point on the graph of a relation, then the relation is not a function. So you have to pass the vertical line test in order to be a function. Use the vertical line test, which graphs represent the functions. Make sure you write this down on your paper. So I have the luxury, I get a vertical line already. I've already got it created. So if you look at A, I'm going to take my vertical line and pass it through this relation here. If you look at this point on my graph, I have 2 points that cross my vertical line. So A is not a function. When we look at B, we want to make sure that none of these dots have the same x coordinate. So here I'm fine, here I'm fine, this one is fine, this one is fine, this one is fine, and this one is fine. So B is a function. And then last but not least, I'm going to take my line and just drag it across. I'm looking for any places where it touches the line twice in the same spot. And I see no. So that is also a function. So on your paper, I want you to take a vertical line, go ahead and create the vertical line, and just for fun, make him into a stick figure. So on your paper, make a nice little stick figure. And I'm asking you to do these things to verify that you've actually listened to the notes that I've given you. So when I see your paper later, I can tell that you've listened carefully to the notes that you're supposed to be taking. All right, tons of vocab. So take a moment, pause this recording, and write down these 4 vocabulary words. A function rule is an equation that represents an output value in terms of an input value. So if I say to create a function rule, I want you to come up with the equation that relates the input and output values. Usually a function rule will be written in function notation, and this is straight from your glossary. If f is the name of a function, the function notation, now work with me here, f of x. So see how parentheses up until now had represented multiplication. In function notation, this is not multiplication. This just means f of x, or a function in terms of x. Shows the function name f and also represents the range value f of x for the domain value x. So this is our new y. When you're using function notation, you don't use y equals, you use f of x equals. You read the function notation f of x as f of x, or a function of x. Note that f of x does not mean f times x. The independent variable, my science teacher will love me for helping you guys with this, x represents the input of the function. The dependent variable, f of x, represents the output. So x is the independent variable, y or f of x is the dependent variable. Okay, so let's see how that operates in a real function. So for f of x equals negative 4x plus 1, what is the output for the given input? So we're going to input negative 2 into our function. So we're going to take out the x and we're going to put in negative 2. My recommendation is anytime you are inputting into a function that you replace it including the parentheses. So I'm going to go negative 4 parenthesis negative 2 close parenthesis plus 1. So what I'm doing is I'm actually applying the function to my input. So I'm going to take my negative 2, I'm going to multiply it by negative 4 to get 8, and 8 plus 1 is 9. So f of negative 2 equals 9. All right, I'm going to do the same thing for 0. So I'm going to take out x, put in 0. Negative 4 times 0 is 0, and 0 plus 1 is 1. Lastly but not leastly, I'm going to do it for 5. Negative 4 times 5 plus 1. And negative 4 times 5 is negative 20 plus 1 is negative 19. All right, let's see how this applies to a real world problem. For those of you guys looking ahead, this is a great kind of basic problem. You can make this a little bit more difficult if you're looking for a portfolio problem. But let's see how we apply that to a word problem. You're buying bottles of a sports drink for a softball team. Each bottle costs $1.19. What function rule models the total cost of a purchase? Evaluate the function for 15 bottles. Okay, so here's where we're going to relate all these things together. We have a total cost. Our total cost is whatever our cost per bottle times the number of bottles that we're going to buy. So we need to define some variables. We're going to let B equals number of bottles bought and C of B equal the total cost. So let's take that format and write C of B equals, so that's the total cost, is my equal sign. Cost per bottle is $1.19 times number of bottles bought. Boom. Okay, and then now we are going to input. So we know that we want to find C of 15 bottles. 1.19 times 15. And that is $17.85. Let me put a dollar sign right here. So and that's how you use this in a real world modeling situation. All right, take a moment, review what we talked about, and write a little summary. Make sure to include the learning objective in your summary. You can definitely include anything that stood out to you that was important to the topic. Thank you guys.